Welcome everybody to Images in Plane Mirrors. We are going to learn how to figure out how to draw a ray diagram using our plane mirrors. A mirror image is basically not the exact same copy. It's not even real. It's something we see in the mirror, but the real thing is us outside the mirror. When we look at an ambulance, if you look in your rearview mirror, the words are not backwards, but if you actually look right at an ambulance, it's spelled backwards, so that when you look in the mirror, it actually says ambulance and you know what it is. The characteristics of an image in a plane mirror is that they do what we call a lateral inversion. The orientation is backwards and reverse order. You all know this. When you look at yourself in the mirror, you hold up your right hand, but in the mirror, it looks like you're holding up your left hand. That's what we call a lateral inversion. They are backwards and in reverse order. When we locate the images, the idea is our eye here is looking, so the object comes in and the angle of incidence and the reflected angle are the same, and it reflects back out. Well, our eye sees that light travels in a straight line, so the image appears behind the mirror, in the space behind the mirror. To find out where the eye sees the image, all we have to do is, this is the source, the incident rays are coming in, it gets reflected to our eye and we extend it back, and the apparent image is back here behind the mirror, always the same distance from the mirror that it was on the real side, but on the image side, it's back here. A virtual image is what we call the image because it appears behind the mirror. If it was a real image, it would appear on the same side as the mirror as the actual object. But because it's behind the mirror, we call it virtual. It is not real, it's kind of pretend. So virtual images, the objects on this side of the mirror, our eye sees the light going in and reflecting up to the top of the object, and it reflects down to see the image. There are two ways. The first is using perpendicular lines. That's the easiest way. It's what I call the equidistance way. And then the second is using our angles of incidence and our angles of reflection to draw ray diagrams. The distance from the object to the mirror is always the same. So, and you guys know this, if you're standing a meter away from the mirror, it looks like in the mirror, your image is a mirror 1 meter away. As you go closer to the image and finally you touch your nose to the mirror, then your image looks like it's touching its nose to the mirror too. So that's what the perpendicular line method is. We're just going to use that. So what it looks like is if I take this point and measure this line, let's say it's 10 centimeters, then over here it's 10 centimeters. This is 8, this is 8, 7, 7, 5, 5, 4, 4. They're always the same distance, but they also have to be very straight lines. They have to be perpendicular, and perpendicular means that it's hitting here at 90 degrees. Now, this one is a little bit harder. It actually isn't very hard because you just have to draw 2 lines, but once you get the hang of it, it becomes very easy. So if you're drawing from A, and then you also label B, your first step is you're going to draw a ray, an incident ray that goes straight into the mirror. It has to hit at 90 degrees. Because it's 90 degrees, there's the angle of incidence is 0, the angle of reflection, so it bounces straight back out. The second line you're going to draw, it doesn't matter where you draw it or how you draw it straight in, get your normal, and then you measure the angle of incident, the angle of reflection, and that's how you get the line that comes out. Once you have this, you extend it out, you put dotted lines because it's not real, it's virtual, it's going into the mirror, and you extend this reflected ray, dot, 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 and where they meet is the point A. You do the same thing for B. So you draw one line straight in, and then that bounces straight back out. Then you draw an angle in, put the normal, measure the angle of incidence. If this is 10, this is 10, that's your angle of reflection. Then you extend out your reflected ray, and where those two meet, that's your point B. And now you can draw your image. Here's a little video to show you those steps that you can watch over and over and over and over again. So method 1, equidistance. Measure the distance from the point to the mirror, then measure the same distance.
Okay, the first method to figure out how to draw an image is the equidistance. Equi means same distance. So if you measure from A to the mirror, you get 4.5. No, 4.8, sorry. Then I measure over here and I get another 4.8. So I draw a little dot. Then from D to the mirror is 3.7. So then I go from the mirror to the other side, 3.7, and I draw a little dot. From C to the mirror is 2.8. So then I measure over here, 2.8, and then I finally measure B. To the mirror is 3.4, and then over here I go and I measure 3.4. My final step, connect the dots. When we put our labels, this is A prime for image, D prime, C prime, B prime. All the points are the same distance from the mirror, and the image is flipped laterally and reversed. So closer to the mirror, C, C. In the second method, you have to use ray diagrams. In a ray diagram, your first ray is going to go straight to the mirror and reflect straight back. The second ray is going to go at an angle, and then you have to measure the reflected ray at the same angle, and then you repeat for all the points. So what it's going to look like is the first one, I go straight into the mirror, like that, and this one is going to reflect straight back. So then what I do is I just extend that out like a dotted line into the mirror. My second point, I'm going to go in to the mirror like this. Doesn't matter where I do it. I have to remember that there's a normal here. And then I measure the angle. So the incident angle here is 10, almost 18. So over here I'm going to go 10, and over here 18. Draw a little line. And that's my reflected ray. And in the mirror, it's going to go back to, and where they meet is D. I would then have to do this for the other points. So for instance, in C, I draw a straight line in. That one's going to get reflected back. And then I extend it into the mirror. I now drew another angle, something on an angle here. That's my incident ray. I actually have a normal there, so I don't have to draw one. And this one's going 10, 20, so I go 10, 20. Draw my reflected ray. And then where these two meet, that's C prime. And that would be 2 of the points. You can do it for all 4 points, or you can just sort of extrapolate from there.
So that's how you do it. I put that in so you can watch it over and over again. Now the last, uh-oh, I forgot to shut down.
With a saw, a straight.
You don't even want to know what that is, folks. Okay, so the last thing is the 4 characteristics of all images. We call this SALT. So all the images that we're going to be doing in the next little while, we describe how big they are, their size, their attitude. Is it upright or inverted? Inverted means upside down or backwards. And location, is it closer to the mirror, same distance from the mirror, further away from the mirror? And the type, is it real on the same side as the mirror as the object, or virtual behind the mirror? So if we look in a plane mirror, that's a flat mirror, the size, they're always the same size. When you're standing in a plane mirror, you look the same if it's a regular plane mirror. The attitude, it's laterally inverted, which means it's flipped on the horizontal and it's the reverse order. The location, always the same distance, equidistance. And the type, it's a virtual image. And there you have it, folks.